Good afternoon, everyone. My name is Jerry Quinn, and on behalf of AFAA New England, I'd like to thank you for joining us today. Before we get started, I'd like to thank our sponsors for making AFAA New England programming possible. So we have Fire Command Systems, J&M Brown Company, Mammoth Fire Alarms, Norel Service Company, Siemens Smart Infrastructure Division, Space Age Electronics, and TC Life Safety. Thanks again to all of the sponsors. So today we have the privilege of having Ed Ledoux of BR+A as our presenter. Ed is going to discuss emergency elevator service, a multitude of topics, subjects on that topic. And Ed, if you could take it from here.
Okay, great. Thank you. Thank you, Jerry. Appreciate it. Appreciate the time. Thank you for everybody for joining us today. Giving us some of your valuable lunchtime opportunity here. I know it's tough, but I think it's a nice, convenient opportunity for us all to touch base, get together, and update on some key issues here in the industry. We're going to talk a little bit about emergency elevator service, what I call beyond recall. So the general issues that I think a lot of us are familiar with. In terms of elevator recall functions and emergency elevator functions, but with some new twists and some new developments here in the industry. Our agenda for today is we'll just do a general introduction here, and then an overview of the topic. Talk a little bit about the applicable codes, some key concepts. Just a refresher on some of the key concepts, as well as some compliance strategies, and then we'll wrap up. With a summary of what we've discussed. Myself, again, my name is Ed Ledoux, Senior Associate, BR+A Consulting Engineers, I'm a technical committee member of the NFPA 3 and 4 committees on integrated testing and commissioning of fire protection systems. NICET Level 4 certification on fire alarm systems, and over 30 years experience in the industry. A couple comments here on BR+A. We're a large organization of about 420 employees, 10 local offices, and employee-owned company, with certified over 100 certified sustainable projects, including LEED Platinum, Gold, Silver certified, and 12 net zero energy projects. We're ranked number 15 largest in consulting specifying engineer. We offer full range of services: mechanical, electrical, plumbing, and fire protection engineering, as well as sustainability consulting, infrastructure design, commissioning, and low voltage technologies, security and surveillance systems as well, and of course lighting design as well. That's a growing part of the business as well. Dedicated lighting design teams. Markets are primarily geared towards higher education, corporate and development type buildings, as well as infrastructure, healthcare, which is really our sweet spot from the beginning of the company. And as well as a lot of proton particle therapy projects worldwide. So with regard to emergency elevator service, again, beyond recall, we're all familiar with the technologies that we use to initiate recall, but in general, the intent of emergency elevator service is to ensure that a safe elevator operation during a fire emergency. Traditionally, it's limited to elevator recall functions, but with new code developments, research coming throughout the industry, we're starting to incorporate some new features and functions into these these aspects of building construction to allow expanded use of elevators during fire and other emergencies. With regard to code, there's a lot of, it's a wild west out there in terms of codes. As we all know, codes vary from jurisdiction to jurisdiction, from inspector to inspector even. So it's a little bit difficult to nail down to wrangle all of the different codes, but what we'll do for the purposes of this discussion is we'll primarily focus on the key model building code, IBC 2015 edition, which is in general the most widely applied version of the IBC. In addition, we'll talk a little bit about ASME or ANSI A17.1, which is the handbook, the Bible for elevators and escalators conveying systems. And we'll talk a little bit about NFPA 72, the 2013 edition, as our primary reference here, because it is the most widely applied NFPA standard in the New England area. Again, some of the requirements going to vary somewhat from edition to edition, but in the interest of keeping a uniform discussion line of discussion here, we'll just pretty much focus on the signaling code. So key concepts, the phase one operation. The question is, why do we recall? And it's important. We all know this. We all have been doing this for our entire careers here, and sometimes we take for granted a little bit as to why we exactly do these things. But if you're interested, chime in on the chat. But rhetorically, why do we recall? We recall to reduce the possibility of passengers being taken to a fire floor and allow the firefighters to use elevators for firefighting operations. So we capture the cabs, we bring the cabs, we ensure the cabs are recalled so that they don't land at a fire floor, and we also ensure that they're captured and available for firefighter use during firefighting operations. Okay, so again, we're overriding that operation to return the cabs to a designated safe location. It's important to recognize, and those of us in the fire alarm industry kind of miss this sometimes, that the recall functions occur both automatically or manually. Typically or historically, the elevator recall is initiated by an elevator lobby smoke detector, but they also can be, recall can be manually initiated by firefighter override key. Primary recall, automatic, that is the primary level of recall. Activation of a lobby smoke detector would typically return the cabs to the main egress level. Alternate recall is established so that we'll return the cabs to a safe location other than the main egress level if in the event that the alarm occurs on that main egress level. Phase two operation, again, something that those of us in the fire alarm industry tend to skip over because there's typically not much, we're not typically directly involved with initiating or controlling phase two operation. That phase two emergency in-car operation it overrides phase one recall. It's typically key activated by a firefighter in the cab, and they overrides the recall operation and is enabled by firefighter key in their cab. It allows the fire department to override that recall function and gives them full use and operation of the elevators during firefighting and rescue operations. I want to emphasize, phase two operation allows the firefighters to use the elevators during firefighter operations, presumably while there's a fire event in the building. So these guys are taking great risk to capture the elevators and utilize the cab during a fire event. It is crucial to monitor these systems at all times. A quick comment on elevator lobby communications. This is an aspect somewhat separate from the recall functions and the emergency elevator service functions, but I thought it was important that we touch base on this topic as well because it's a hot button item in the industry. The two-way intercom or communication systems require the call stations at each elevator landing. Each elevator landing that's above grade or below grade, they do not landings that do not discharge directly to grade. These call stations are intended to call to a master station located at a fire command center, central control point. If the central control point or fire command center is not constantly attended, the call stations will need to dial out to a monitored location, a 24/7 constantly attended location, or to 911. It's important to note that these elevator lobby communication systems are technically not considered an area of refuge or an area of rescue assistance system. These systems are required by section chapter 10, 10.0.8 for accessible egress within the accessible egress chapter of IBC 2015. It's important to note that that section does not invoke the strict requirements of NFPA 72. So it essentially dictates two-way communications, the ability to call for assistance from an elevator lobby, so that if the elevators have been taken out of service or recalled and someone is on an upper level floor, wheelchair, handicap, wheelchair bound person would be able to go to the elevator lobby and call for assistance. So it's simply a communication system that's required for accessible egress. And in and of itself, certainly by the base language of the IBC 2015, does not invoke 72 requirements for cable survivability and operator product listing and operator requirements. In terms of new developments, this is kind of the heart of the issue, is fire service access elevators. Fire service access elevators, the requirements stem out of NIST, the National Institute of Science and Technology research that showed the need to enhance firefighting operations. The fire service access elevators permit the use of, the requirements permit the use of elevators to reach upper levels of a building, to stage firefighter operations below a fire event, and would significantly improve response time. So again, we'd have fire service access elevators. The fire service personnel would be able to utilize the elevator to stage below a fire event and have direct access to the fire floor. When we introduce fire service access elevators, it should be noted that fire service access elevators will recall automatically upon any alarm in the building. Somewhat different from your typical recall functions, which are initiated by a smoke detector at an elevator lobby. So only the lobby detectors would recall the cabs to ensure we're not opening the cabs at a fire event. In this case, fire service access elevators are for fire service use, and they will be recalled automatically on any alarm. So when the emergency responders arrive at the building, they will have cabs ready, parked, and available for their use. The general requirements for fire service access elevators, there are some key criteria. These are primarily architectural type concerns. But 403.6 IBC 403.6 requires high-rise buildings, 120 feet or higher, to have at least 2 fire service access elevators. In some instances, if there's only one elevator in a building, for example, then it obviously 2 would not be required. If one is sufficient to meet the requirements for the building size and occupancy, then a single elevator would be permitted. But primarily with a building 120 feet or higher, you'd have 2 fire service access elevators. The lobby shall comply with IBC Chapter 30, 3007. It includes direct access to an exit enclosure. So we have the elevator lobby here with a direct connection to an egress stair. Requires a 1-hour smoke barrier. So it's a smoke protected construction. Has a standpipe and an adjacent stairwell. And it's a minimum 150 square feet. There's also a requirement for signage so that the elevators are readily identifiable as fire service access elevators. Another new development is occupant evacuation elevators. We're not going to really get into the requirements for occupant evacuation elevators in this presentation. We could do a 1-hour presentation or more on these alone. But we just wanted to point a couple of key issues. Chapter 30, Section 3008 provides for elevators to be designed for occupant self-evacuation. I think we all recognize that that's a big departure from the typical procedure, right? We are always told, do not use the elevators in the event of a fire. Use the exit stairways, et cetera. So these are intended for self-evacuation. And in that regard, there are a lot of critical features that have to be built into elevators that are designated as occupant evacuation elevators. The requirement is intended primarily for tall buildings, 420 feet or higher, where additional exit stairwell would be required per 403.5.2. Again, the high-rise requirements, when we have a building that's 420 feet or higher, it introduces a requirement for a third exit stairwell. As an alternative to our third exit stairway, which is quite a painful the exit stairwell, the third exit is painful for a lot of architects or owners that want to maximize their floor space, rentable, leasable floor space, or usable floor space. That's a lot of space to give up. So the code does permit the designation of occupant evacuation elevators as an alternative to the third stairwell. The code permits any elevator to be designated as an occupant evacuation elevator, regardless of building height. So theoretically, a 5-story building can be used, could utilize occupant evacuation elevators. If you had an inpatient healthcare facility and you just wanted to designate all of the elevators to be used for occupant evacuation, we could certainly do so. And all of these requirements would apply. When used, all passenger elevators would have to comply. So there is no set aside designated occupant evacuation elevators. All the passenger elevators in the building would have to comply with the requirements. And there are strict requirements to the construction, operation, and monitoring of monitoring and firefighting operations, structural integrity, the shaft construction, the monitoring of the operation, emergency power, sprinkler systems, evacuation signal zoning, and firefighter operations. There's a lot of information, a lot of requirement built in when we get to occupant evacuation elevators. Again, not going to drill down into that too much because most of us on this call, I think, we don't have a lot of call for these super high-rise buildings here in New England, and the codes are new and really not very well established. It becomes more of a performance-based design, and we have to look at some of this other language too before we can really fully embrace the requirements and the solutions for this application. The heart of the fire service access elevator requirements are Chapter 30 of IBC, specifically 3007 establishes the requirements for fire service access elevators to include, and some of this is not different from what we do here in Massachusetts, certainly, and a lot of New England, where sprinklers are becoming more and more exempt from the elevators and the elevator machine rooms. So with regard to fire service access elevators, no sprinklers would be allowed. Have to take steps to protect water, from water infiltration into the fire service access elevator hoistway. There need to be trench drains or curbing or floor slopes that would help to prevent water from outside the elevator lobbies to infiltrating the lobbies in the hoistway specifically. We can't disconnect the power when the fire service access elevators are in use by the fire service. We don't want to disconnect the power on them and disable the cabs. So we would not allow, consistent with the no sprinkler rule, we would not allow power disconnect. Lighting. While the fire service access elevator phase 2 operation, the manual override, the in-service in-car operation is active, the hoistway shall be automatically illuminated. In addition, we'd provide manual lighting control from the Fire Command Center. This is typically done by the elevator status panel and control panel that's located in the Fire Command Center, but this is in consideration when the fire service may in fact want to manually override that automatic activation of the lighting. Hard to imagine why that would want to happen, but anything that we have automatic control of in a building of this type would have to be subject to some level of manual override control from Fire Command. In addition, we need to monitor the status of the fire service elevators. The Section 307 points us to NFPA 72 requirements for monitoring the status of the elevators. It also requires electrical power at Type 60, Class 2, Level 1 standby power. In addition, there's the requirement for the protection of the wiring cabling. So all wiring located outside the elevator hoistway and machine room that serve fire service access elevators shall have a 2-hour fire resistance rating. It's typically going to be a CI or an MI type cable for all the wiring and cables that serve the fire service access elevators. Drilling down a little bit here to the NFPA 72, the specific requirements of NFPA 72 21.5 essentially requires these 3 items. Again, monitoring of the main and emergency power systems, monitoring of elevator status, including the location of each cab, the direction of travel, and whether or not the cabs are occupied. So this gives the fire service important information at the Fire Command Center for the status and level of operation of the cabs. In addition, it requires the monitoring of the temperature and the presence of smoke in associated lobbies and machine room. So this is an interesting change for us to monitor the heat of smoke and heat in the elevator lobbies. Let's take a quick look at what the intent of that monitoring of the elevator lobbies is. 21.5 parent 3. Under the current 2013 edition, again, it just simply says monitor the temperature and the presence of smoke in associated lobbies and machine room. It doesn't give us any there's no clarifying annex material on that. So, you could drive a boatload of change orders through that language. We have to use our own engineering judgment as to what the intent of this language is. There is some discussion in 72 in the handbook, but for all intents and purposes, under the 2013 edition, there is very little guidance on the requirements for monitoring of the temperature and presence of smoke in these areas. In 2016, same language. Monitor the temperature and presence of smoke, and there's no clarifying annex material. What we've done is we've looked through, even though we said that we want to only follow the one edition of NFPA 72, we had to jump all the way to the 2019 edition of NFPA 72 to find some guidance on what was really intent here. So under the 2019 edition, 21.5 remains consistent with the prior editions, other than, for some strange reason I haven't been able to discern, they restructured it to eliminate the itemization of those items one through 3. There's just one paragraph that says monitor the power, monitor the ventilation, monitor the presence of smoke and heat. It also, under the prior edition, there was this sort of reference to, under 21.5.2, a reference to 18.11 emergency services interface. Unfortunately, with the prior editions, that emergency services interface, again, is somewhat undefined, other than to say all the information has to be conveniently organized, clear, and understandable to the fire service. And there's been a lot of talk about standardizing the interfaces for fire alarm panels, but I'm not sure I'm going to see that in my career until all the manufacturers start developing a panel that looks the same, has the same form and function and operator interface. So what's happened here is they've now dropped this reference to the emergency services interface, a uniform emergency services interface, but they have provided some annex material. So Annex A 21.5 has updated to provide some guidance on the enunciation of the presence of smoke and heat in elevator lobbies and machine rooms. And it's advised us to, it's identified 3 different heat conditions that we should pick up: normal, 90 degrees or less, a normal condition; monitor or a supervisory condition above 90 degrees, or in a range between 90 and 135 degrees, and an unsafe condition above 135 degrees. Further, the language identifies some enunciation that should be provided. So in the smoke event, a normal no smoke event would be no indication. An alarm condition, we would have a LED. So we would have to enunciate an alarm condition at the fire command center when smoke does occur within a fire service access lobby or machine room. And with regard to heat, again, normal, we could have a green LED, but really no indication is required as long as everything's normal. And we would have a monitor or a supervisory yellow LED when you have this elevated level of heat. Again, between 90 and 135 degrees, it's a pretty broad range, and it's pretty hot. So, so we're looking at picking up a supervisory condition and lighting a yellow LED whenever the level of heat in the lobbies or machine room exceed 90 degrees. Under the 2019 edition, we also differentiate between an unsafe condition, a red LED to indicate that the ambient temperature in the elevator lobby or machine room has exceeded 135 degrees. So in terms of compliance strategies, just to talk a little bit about the sequence, phase 2 operation will bypass automatic, phase 1 recall, monitor for the presence of heat and smoke in the elevator lobbies and machine rooms, activate hoistway lighting, show status of the elevators, location, direction, occupancy at the fire command center. And those are the key issues there. Again, these are all automated sequences. So we're going to supervise that phase 2 operation, and then we're going to initiate these other the monitoring and reporting of these other conditions. A strategy with a strategy for the smoke and heat detection. There are a couple of different strategies. Interesting to see manufacturers respond to this challenge. As I see it, the primary approaches would be to utilize a combination multi-sensor analog smoke heat detector, or dual detectors. The devices must be able to differentiate, particularly if you use a multi-sensor detector. That detector needs to be able to differentiate between the smoke and the heat response. You have to be able to get two signals out of it. Again, the term multi-sensor implies that it's two separate sensors, and we can theoretically get two separate signals. This is not to be confused with a multi-criteria detector. A multi-criteria detector utilizes multiple sensors, but it's only a single output. A little bit of smoke, a little bit of heat gives us an alarm, as opposed to multi-sensor. A lot of smoke or a lot of heat will get us an alarm, but so it's really important to understand the distinction between multi-sensor and multi-criteria. Multi-criteria is one output. Multi-sensor should give us two outputs. So it's important to recognize that you're going to be able to differentiate between the smoke and heat response. Some analog sensors will support multiple set points. So, for example, a lot of analog sensors will give us a low temp, supervisory low temp signal. We use them in fire pump rooms a lot, where a 40-degree signal will give us a supervisory low temp alarm. In this case, now we're looking for an analog sensor that can give us additional set points. So the analog thermal sensor should be able to give us about a 90-degree supervisory pre-alarm. Now, in some cases, some of the detectors, as I understand it, their lowest response level is maybe 100 degrees. I don't think that's a big deal breaker. It's above 90 degrees. That's okay. But generally, to follow the annex material, we're looking at above 90. We'd like to see a supervisory or pre-alarm condition. And then at 135 degrees, we'd like to see a full-blown alarm condition so that we can provide that monitoring, the yellow LED for the elevated heat, the red LED on heat, with the heat detection on once we hit 135. An alternative approach to that would be to utilize a standalone temperature sensor. So this is a standalone sensor, a thermistor type temperature sensor or transmitter that provides a 4 to 20 mil signal. Some manufacturers some of the fire alarm manufacturers can have a listed 4 to 20 mil analog input module that can accept this 4 to 20 mil signal. And then that module will serve as the interface between the thermostat and the fire alarm control unit. These have gives us a lot of program flexibility so that we can then correlate different analog signals, the 4 to 20 mil signals that correspond to different temperatures. So you'd be able to pick up the below 90, above 90, above 110, above 130. You could pick up a lot more signals, which is important in when we're using occupant evacuation elevators more so, certainly, but it is certainly a viable approach with fire service access elevators as well. It becomes much more complex in terms of system programming. I personally haven't seen this employed on any of my projects yet, but I understand we're doing it quite a bit on the West Coast in other projects. So that's the approach on the detection side. With regard to monitoring, we want to enunciate the presence of smoke and heat. And we want to enunciate the power system monitoring. That is typically by Division 26. So you're going to have status indicators and controls of the generators, the emergency power systems, automatic transfer switches, all that emergency power system monitoring is by the Division 26 electrical contract. Elevator status control, again, location of the cabs, direction of travel, whether they're occupied, that typically should be the purview of the elevator contractor or Division 14. In terms of the smoke and heat enunciation, this is an example of a simple panel, LED panel, LED enunciation type scheme where you'd have banks of LED modules identifying that they're supervising the elevator lobbies, monitoring which cabs 1, 2. Typically, these multiple access elevators are going to be served by a common lobby. So we're identifying lobby elevator 1 and 2, which are fire service access elevators, and we're providing separate LED enunciation for the smoke activation and the heat activation within each floor. So that's a basic approach to how we would satisfy the enunciation requirements of the current code. If we were following 2019, based on the annex material, you might be looking at 3 LEDs, a red LED for smoke, a yellow LED for elevated heat, and then another red LED for heat above 135. So it might get a little bit more complex. Personally, I think it's probably overly complex and really simply just not necessary, and certainly not dictated by the current version of 72. Another example of a status monitoring scheme would involve a custom panel. This is a large graphic panel which has each elevator cab identified individually, whether they're passenger elevators, freight elevators, occupant evacuation elevators, fire service access elevators, you name it. So this is a very large building, and as an occupant evacuation elevator panel, again, typically we're talking about buildings that are in excess of 50, 60 stories. That are being used for occupant self-evacuation. And in this case, what we're looking at is a complex graphic panel, custom panel that would identify each individual cab by level, and then individual temperatures within each lobby. So these puppies light up like a Christmas tree, I guess, if they're when they're in use. But certainly very complex and interesting use. The other thing that they would do is with the occupant evacuation, you have to have the ability to be able to call or command a cab to a particular floor. So this has an array of switches that would send signals to command the elevators to given floor. Again, I think that level of controls typically would belong with the fire, the elevator contractor, but in this case, to develop a uniform strategy for command and control status and status reporting of the cabs, it's certainly I can see where it could be a helpful tool for the fire service. Kind of rushing through here, but basically in summary, we have, to summarize, phase 1 elevator recall, both automatic and manual recall functions, and the primary and alternate recall levels. Most importantly, the general passenger elevators, they activate on designated detectors. So only a lobby detector will recall a cab. Under phase 2, this is the phase 2 emergency in-car service. It's initiated by firefighter override by typically within the cab. It's crucial during a life safety operation. Emergency response, rescue operations. It's become crucial in these large high-rise buildings to have access for the cabs. And when it comes to fire service access elevators, again, these are going to recall on any building alarm. Okay, so that the cabs are ready for use upon fire department arrival. We have to monitor both the presence of heat and smoke, and we have to enunciate that at the Fire Command Center. That's where we're at. I want to thank you all. Thank you all for taking the opportunity to meet with us here. And if you'd like to, if we have any questions, I'd be interested in hearing what we have to say. Questions or comments?
Yeah, thanks, Ed. Jerry Quinn here. Great job today. Very interesting topic. So really appreciate you taking the time to explain this to us and kind of walk us through it. It really requires that we have a different mindset, to the way we've thought about elevators in the past. And I think that's something that's on a lot of people's minds now. And I'm curious, one of the questions I got prior is, are you seeing the fire service access elevator requirements on current projects in New England? How prevalent is this today?
Well, it's interesting, Jerry, too, because this is, not necessarily new, but it's certainly newly envisioned.
Mm-hmm.
But we see it coming in on current projects that are being permitted, projects that are in design and in construction under the current 9th edition of the Massachusetts Building Code. I can't speak to whether or not we've seen it in other states in New England. I'm curious as to whether or not anyone else has seen these features required on their projects as well. But no, projects that are currently in construction, yes, we see it in design.
Okay, great, thank you. So I'd like to open it up to the floor. Does anyone have any questions? Feel free to unmute yourself, and you can ask Ed a question. All right.
Answered all the questions.
I guess you answered them all, Ed. Great job. So we'll give everyone back 15 minutes or so here. So thanks again, Ed. Really appreciate it. And please look forward to look for future AFAA New England webinars. We'll have one coming up in January. So thanks, everyone. Take care.